All right, now for my favorite part. Earth's internal heat is a source of non-depletable energy. So unlike most forms of renewable energy, geothermal energy does not come from the sun. Geothermal energy is heat that comes from the natural radioactive decay of elements deep within the earth. Um, Convection currents in Earth's mantle bring up hot magma towards the surface. And where magma comes in close contact with groundwater, that groundwater is actually heated. And the pressure of this hot groundwater sometimes drives it to the surface where it's visibly manifest by geysers and hot springs, like the one that's in like Yellowstone National Park. So where hot groundwater does not naturally rise to the surface, humans may be able to reach it by drilling. So many countries obtain clean, renewable energy from this geothermal source. The US, China, and Iceland all have substantial geothermal resources, and they're the largest geothermal energy producers. We have geothermal um, energy sources and systems right here in Paulding County, and one of the largest ones that I've ever seen is right below our new hospital. So another approach to tapping into this thermal resource could be the use of ground source heat pumps. And they transfer heat from the ground to a building by taking advantage of this high thermal mass of the ground. So Earth's temperature, about 3 meters or 10 feet underground, remains fairly constant all year long, like 10 degrees to 15 degrees Celsius. So because the ground retains the sun's heat more effectively than like air, we can take advantage of this by using a heat and cooling residential commercial building system. So, although the heat trapped by the ground source heat pumps are often referred to as geothermal, it comes not from geothermal energy, but from solar energy. All right, so how does this heat pump thing work? So let's see if you can follow me. This diagram shows a ground source heat pump transferring heat from the ground to the house. In contrast to the geothermal systems that we just talked about, ground source heat pumps do not remove steam or hot water from the ground. In much the same way that any solar water heating system works, a ground source heat pump cycles fluid through pipes that are buried underground. In winter, this fluid absorbs heat from underground, and then the slightly warmed fluid is sent back to the house and compressed in a heat pump to increase its temperature even more, and then that heat is distributed throughout the house, and that's how we warm the house. The fluid is then allowed to expand, which, as the fluid expands, it cools and it runs through the cycle all over again. All right, in summertime, the ground temperature is cooler than the actual ambient air temperature. So the fluid is pulled into the ground and it's actually cooled underground. And this cooled fluid returns to the house and releases the cool air system. All right, so ground source heat pumps can be installed anywhere in the world, like regardless of whether there's a geothermal energy accessible pump or thing in the vicinity. All right, so the operation of this pump requires some energy though. But in most cases, the system uses like 30 to 70% less energy to heat and cool buildings than your standard air conditioner or furnace. So, if you've ever heard of some homes having what we call a heat pump, as they call it, it works much like this here. And it's just a very effective way to have climate control. A fuel cell is an electrical chemical device that converts fuel, like hydrogen, into an electrical current. A fuel cell operates much like a common battery, but with one key difference. In a battery, the electricity is generated by a reaction between two chemicals, like nickel and cadmium. When this happens in a closed container, with no additional materials to be added, eventually the reaction slows and stops. And that's when your battery goes dead. In a fuel cell, however, the reaction they're added continuously to the actual cell, so the cell produces electricity for as long as it continues to receive fuel. And electrolysis is the application of an electrical current to water molecules to split them into a hydrogen and oxygen. So let's talk about these hydrogen fuel cells. So hydrogen gas enters the cell from some external source. And hydrogen, remember we've talked about, it's really just a proton. So protons from the hydrogen molecule, they pass through a membrane, while the electrons that flow around that hydrogen produce an electrical current. And water is the only waste product of this reaction. So, in a fuel cell vehicle, hydrogen is the fuel that reacts with oxygen to provide the electricity to run the motor, and it releases water as its waste byproduct. Although there's many different types of these hydrogen fuel cell things, the basic process forces protons from hydrogen gas through a membrane while the electrons take a different path. And so this movement of protons in one direction and electrons in another direction generates an electrical current. Using a hydrogen fuel cell to generate electricity requires a supply of hydrogen, so which is a combustible gas. Supplying hydrogen is a challenge because free hydrogen gas is relatively rare in nature and because the gas is explosive. So hydrogen tends to bond with other molecules, forming compounds like water and methane. So producing hydrogen gas requires separating it from these other compounds, either by the use of heat or electricity. So currently, most commercial available hydrogen production places, it's a very energy intensive process of burning natural gas in order to extract the hydrogen. So, and what happens when you burn natural gas? Carbon dioxide is the waste product of that combustion. And in an alternative process that we've talked about, known as electrolysis, that electrical current is applied to water, which actually splits into hydrogen and oxygen. And so energy scientists are looking for other ways to obtain that hydrogen, like under certain conditions, like photosynthetic algae and even some bacteria, or using sunlight as the energy source, anything that we can do to basically harness hydrogen gas. So I guess you should talk about if it's viable or not to use hydrogen. Some policymakers consider hydrogen fuel cells to be the future, and the solutions are going to solve the world's energy problems. And then hydrogen fuel cells are about 80% efficient themselves, and converting to potential energy from oxygen and hydrogen into electricity with water is the only byproduct is pretty fantastic. But thermal fuels, like fossil fuels, power plants, are only 35 to 55% efficient, and they produce a wide range of pollutants and byproducts. So there are some people who believe that hydrogen fuel cells are like the wave of the future and the solution. But, all right, despite those many advantages, hydrogen as a fuel has some issues. First, scientists must learn how to obtain some hydrogen without expending a whole bunch of fossil fuels, because that totally defeats the whole purpose. This means that the energy from the hydrogen generating process is now being generated from these non-renewable sources. All right. Secondly, suppliers will need to do a distributing network that is safe, because the delivery of hydrogen to consumers sounds like a terrifying movie in the making. This delivery system, much like how we would deliver like gasoline, would be even twice or three times as volatile, because hydrogen can be stored as a liquid or even as a gas, but storing it in any medium has limitations. All right. And so hydrogen would probably be best if it was stored as a gas in like a large tank under pressure. But vehicles would have to be redesigned with special fuel tanks, and some re-engineering needs to be done here. There's a lot of obstacles for hydrogen. So why is it even being considered as a viable alternative and option? Well, ultimately, hydrogen fueled vehicles could be sustainable. And that means that transportation, because of hydrogen fueled cars, would be the use of an electric motor is a possibility. And electric motors are more efficient than combustion engines. So while an internal combustion engine converts about 20% of the fuel's energy, hydrogen converts 60. So if we generate electricity from hydrogen at an 80% efficiency in the fuel cell, like in the fuel cells, then there it is the answer to our problems. So, however, we must obtain hydrogen from some sort of source that makes sense.